So today, projection of vectors. So this is when we're basically breaking down vectors into components, how we do it. Now, normally the way we do it, as I mentioned to you before, is into horizontal and vertical components. So it's rewritten. So what we end up doing is rewriting it as a projection of the vector on the x and the y axis. Let me show you what I mean. So here's our vector OP. Got magnitude of 2, it's making an angle of 30 degrees. If we were to break that up into its components, I'll just draw in a little triangle here, then the horizontal component would be, using a bit of trig, 2 cos 30, which is the square root of 3. So we'd have root 3i, and in the j direction, we'd have, going up, that one would be 2 cos 60, which is 1. So vertically the component would be j. So root 3i plus j. And that's how we break it into its components. But as I mentioned the other day, we use horizontal and vertical because it's convenient. We can easily relate to that. There's no reason why it has to be. I could project u onto v. Now v is not horizontal, it's not vertical, but I can still project it. And the way you do it is drop perpendiculars to v, like so. Right, so from each end of the vector, we draw a perpendicular line down. I suppose you could think of it like you're standing behind the vector with a torch. And so the shadow would be on the vector. Well, what's the length? Again, I could create a right angled triangle if I just slide that vector back up, and it would be whatever the magnitude is of u times the cosine of that angle. Then to get the vector, because I've got to give it direction, it will now be in the direction of v, but I need to make it the unit vector, otherwise it's going to change the length of it. So I need to make sure. So the unit vector in the direction of v. So here's a way we could write it. It's the magnitude of u, cos theta, times the unit vector in the direction of v. Remember, we know u dot v is magnitude of u times the magnitude of v cosine theta. So therefore, magnitude of u cos theta, remember that was the length of the vector, is u dot v over the magnitude of v. That's a nicer way of doing it. But then we said it was in the direction of the unit vector. So I multiply it by the unit vector in the direction v. But I can make that even nicer because we had a way of working out the unit vector. The unit vector was simply the vector v divided by the magnitude of v. Then look at what we've got in the denominator. We've actually got the magnitude of v squared. And so there's a little formula for working out the projection. U dot v over the magnitude of v squared times whatever the vector v happens to be. But I think of it this way. Rather than think of it as the magnitude of v squared, because remember the magnitude of v squared is also v dot v. I just find that easier to remember. U dot v over v dot v times v. Now, remember, the dot product and division cannot cancel. They're not opposite operations. And the dot product is not multiplication. So I can't, in those parentheses there, go, oh, look, there's a v and a v on top and bottom, and I'll cancel. Well, it doesn't work. We can't do that. So that's why we need to leave it as u dot v over v dot v. A couple of rules. If you're multiplying by a scalar, basically, again, saying it doesn't matter which order you do it in, you could multiply the vector by the scalar first, then project, or you can project the vector first, then multiply by the scalar. You'll get the same answer. And if you're adding two vectors and then projecting, you could project each of the individual ones and then add those. So again, the order is up to you how you do it. Well, let's have a look at this one. Find the length of the projection. So they're only interested in the magnitude here. Remember the magnitude, so this was before we had multiplied it by the unit vector. So it's a dot b over just the magnitude of b, not the magnitude of b squared. So 5 times 3 plus minus 1 times 4 over square root of 3 squared plus 4 squared, and we end up with a scalar because we're talking about a magnitude there. So 11 on 5. That is also known as a scalar projection rather than a vector projection. So you're just interested in the magnitude. So if you see the term scalar projection, that's what they're talking about. Well, let's do an actual vector projection then. So we're going to project u onto v. Make sure you get the notation right. It's the projection of u, and then the subscript is what you're projecting it onto. So projection of u onto v. So it's u dot v over v dot v times v. So on the top, u dot v, 2 times negative 2 plus negative 5 times 3 over v dot v, but v dot v is the magnitude squared, so minus 2 squared plus 3 squared, and then multiplying by the vector v, minus 2i plus 3j, and eventually we come down with our answer there. There it is. 38 on 13 in the horizontal direction, minus 57 on 13 in the vertical direction. And that's it for today.